Okay. Let's start. See. Okay, perfect. Okay, so today we're going to cover the subprograms chapter. I think chapter 9 in the book. And then we'll talk on Wednesday about the implementation of the subprograms. So it will be divided into, because the implementation of the subprograms, it's another chapter in the book. It's chapter 10. So we'll try to cover them both. Now, you can tell me is there anything wrong in the program first? What do you guys think? Is there anything wrong? If not, any comments on the code? Am I a good programmer? Yes.
You could definitely make a function.
Actually, that's a good comment. That's much better now. Correct. So just from this very, what's the main kind of, like, if you want to look at one of the design issues here, what's missing? So we did this function now, we introduced something. So we fixed, right away, we fixed what? Readability of the code, correct? Why? Because now it's like, okay, there's a function and I just call it. What else can we fix using a function? Maintainability. Why?
If you find a bug in one part of the code, you want to edit it, you have to put every single one.
Perfect. That's actually one of the basic stuff that we've learned from the first programming courses. That also, if there is a small, not just bug, also if you want to change something, let's say I want to change or modify something. Imagine I want to add something to the whatever, to the printf or whatever. So I have to go and change this. And this is just an example. What if you have like 100 of these? It's going to take lots of time, right? Or you're going to hire a co-op student, let them do it. Like the easy tasks. So this is much better. Why version 2 is much better? We said we eliminate redundancy, for example, improve code readability. And then as Michael said, we also improve maintainability. So that's very good. So this approach demonstrates the effectiveness of a subprograms, because subprograms are technically can be functions, or it can be like something called procedures, right? So the main idea here, which is basic idea, subprograms provide reusability and abstraction for complex operations, especially if you're building a big code. You need something like a black box, right? Like an abstract thing that you're going to build, which is going to help you, as we said, reusability and other things. Now, subprograms have a single entry point. That's one of the main design things when it comes to the subprograms. What do we mean by that? There is only, you can only enter from the header. That's it. You cannot just in the middle of the program change the function header. So control returns to the calling program after the subprogram finishes execution, of course. So the basics here, subprogram named block with local scope that encapsulates an algorithm. So subprogram doesn't have to be a function, but usually function is the common thing for a subprogram. What is a subprogram call? Explicit request to execute the subprogram. If you, for example, you have definition add, if you just call the add, that's actually the call. What is subprogram header? Basic stuff. These are the header here inside the AB, first part of the subprogram, good name, type, parameters. Okay. Now, interesting thing when it comes to Python, that function definitions are executable in Python. So you can define, so you say define add AB, and then right away you're going to call this, it will work, okay? And all other languages, they are non-executable. Now, when it comes to Python, what's going to happen if you have something like this in Python? If and then inside it, there's a definition of a fun or something, you cannot call this because you didn't arrive to this if condition. Okay, so in different languages, you're going to define your function first. So right away, even if this function is inside an if, it's known for the compiler that there is a function, even if you didn't enter the if, right? But it's known. It's somewhere the compiler knows about this function. But in this case, for the Python, because I'm defining it inside the if condition, the compiler will not even notice this that exists at all until we arrive into this if condition. This is something just in Python. Now, again, we're still in the basics, definition versus declaration. So a definition contains both the header and the body, correct? And declaration is when we just declare it. Now, who's taking C++? I think Michael and other, you've seen declarations all the time, right? In C++, we call them sometimes what? You can also do the prototype, right? And C, I think I'm C++ also. So the declaration provides only the header, right? Without the function inside it. So why sometimes we need the declaration? Because we still didn't even have anything inside the body. Like I'm saying, okay, I'm declaring int calculate number. That's my function. I'm just declaring it like this without even putting anything in the body. Why would be this useful sometimes? Especially because we're using it in C++ and C. From what we learned so far, so what would this give? Yes, Samuel.
It's type information before we see it.
Very good. So technically, it helps a bit the compiler, because if you're saying int calculate number, for example, at least the compiler has an information that the type of this function is going to be int. So this is kind of like one way is type checking, for example. Okay, so that's one way. Another way, so this is especially important in languages where functions may be used before they are defined. In some languages, subprograms need to be declared if you want to use them before they are defined. So what do you mean by that? Let's take a look at this one here, guys. If I have this, let's say I'm declaring this function greet, void greet, and then I have the main function here. Okay. Let me do something. Second. I actually prepared some code so we can just use them right away. Google. So each time I'm copying from the slides, it's very annoying. So I actually prepared the code, but save them in a Google Colab. Recent, okay. Okay, so let's keep this here. Okay, so let's, oh, you can see. Okay, so let's copy this code here. Okay. I have a main, that's in C. I have a main here, and then I'm defining my function here. So if I run this code and see this may not work. Why? Because I'm calling the function before defining it. But if I do this, if I declare it, it will work. Now, if I don't declare it, and I get this from here and I put it here, what's going to happen? Can you see? Should I maybe make it bigger? So if I put the greet, now I'm defining it before the main, it will also work without the declaration. So this is one of the ways to use this. So let's go back here. So what is this needed? This allows the code to be compiled even when the actual code for the function isn't available, for example. Just like helping the compiler know how to navigate through the code. Now, other basic stuff that you need to always know when we are going to call the parameter formal or actual, and if this is the subprogram that you have, these things are called formal parameters, okay? But then when you're calling this function, what you're passing through here, even if you're passing, let's say, A and B are actual parameters. So anything that's passing here, when you're calling is the actual parameters, and when you're defining it is the formal parameter. Now, so formal parameter are thought of as dummy variables. Why they are needed? Because if you remember, each function will have local variables, like local things. So where are these local variables going to be? Inside the memory, all of these kind of things. So you need to have the container, you need to have the types for this. So you need to prepare the containers. So when you go there, you're going to use the containers. So, and the bounding of the storage, as we said, because it's most cases, they are bound to storage only when the subprogram is called. And this, we covered it in the previous chapter. We said these variables will only be using the memory when we call this function. And what will happen to them after that? Get destroyed, right? Depends on the programming language. So the binding of actual and formal parameters is typically done by position. So what do you mean by done by position? That means 5, 10, I'm going to go 5 to the first position here, 10 to the second one. This may seem very obvious, but actually not all programming languages will do this. Some programming languages, when they designed this, they wanted, for example, more flexibility or better readability. So they introduced something else. That's the default. You'll find it in all the programming languages, which is by position. Some other ones, who can tell me, for example, in Python, and other than Python, we can do something else instead of doing this. Annika. Exactly. So this is going to be what? Bind by, called bind by keyword. Okay? That means it's going to be something like this. I'll say if name is name, so here when I call them age equal 30, name equal Alice, right? So even if name comes before age and the formal one, if I'm able, if the language that I'm using support the binding by name or by keyword, I can use them like this. Okay, so this is called keyword parameters. Now, C++, for example, doesn't support this. It only supports by position. It always have its advantage and disadvantage. Now, why is this good? This can help avoid confusion when there are many parameters. Let's say you just want to be very clear. You want to be, actually, if you look at it, it looks like just better. There's no confusion at all. I'm talking about, especially if both of them are names, for example. One is last name, one is first name, right? If I have last name, this one is clear, but if I have name, first name, last name, so it's better. Now, what are the advantages? They can appear in any order in the actual parameter list. And also, as we said, it helps avoid confusion. Now, what are the disadvantages? If, let's assume, would it be a good decision? Let's say Python supports both by position and by parameter. What if they took the decision only by, by keyword, only by keyword without the position? What do you think about the design issue here? Like, what would be an issue for you? Oh, yeah, I thought you have, yeah.
Like a simple function like add, you don't want to specify the variable names.
Very good. So practicality, for example, but there's another one that's the opposite of this. If I'm giving you a function that has like 30 parameters inside it. So you have to actually remember or know or take note of all the exact names of all the parameters is going to be an issue, right? And believe me, there exist functions that have, there's one of the functions that I was using and when I was building one of the machine learning thing, it actually takes at least 20 parameters, right? There is so many different parameters. Usually in these cases, we have default. We're going to take, when you have lots of parameters, they are needed, but some of them, they are going to be most of the time fixed. So you're going to assign a default for them. But yeah, so this one is actually, the user of subprogram must know the names of formal parameters. Restrictions with this approach is that after a keyword parameter appears in the list, all remaining parameters must be keyword. What do you mean by this? So let's say, in this case here, I have income. No, that's a different one. So let's say here, and okay, for example, here I have name and age. And let's say also I have gender, for example, these three. Now, if I do something like, let's say I didn't do, no, it's not going to work. Let's say I do it for me. So I'm calling this function and now I'm passing now Karim, and then the age. I'm using age and then equal 30. Okay. Now I cannot continue using gender, for example, just male. I cannot do that anymore. Whenever I use this, I have to continue with everything like this. Why? Because now the compiler or whatever is going to be confusing between positional and keyword. So you have to actually, it has to be very clear for the compiler all the time. So you want to do the keyword, it's either you do them all keyword, or for example, whenever you start using the keyword, it has to always. And I'm sure 100% that this happened to you if you're using Python, but maybe you didn't know why this is giving error, so you just fixed it. But this is actually the reason. Now, in certain languages, we said C++, Python, Ruby, PHP, and lots of problems, we can do default values for things, and that's good. So this is in Python. It's going to work. Income, exemptions equal 1, tax rate. Would this work in C++? It says here C++, but would this specific line work in C++? Actually, no, because in C++, for example, it has to be the last one when you want. So when you want to use the one with the default, it has to be the last one. Okay, or you have to specify them all. Why is this? Because, yes.
Answer the question, but
Exactly. So because C++ doesn't support names, keyword, it only by position. So it has to follow the position. So it'll be like this. Now, procedure versus function. What is a procedure? The simplest thing that you have to think about is the same exact thing. A procedure, what? There's no return. For example, when you're defining some functions with void, these are called procedure. Okay, function, there's a return. That's the main difference between procedure and function. So we're not going to spend too much time here. Now, the fundamentals of subprograms, you all know this, but formally, like in a formal way, whenever you call the subprogram, what happens? The subprograms inside will execute, but you're going to actually stop, or not stop, like suspend the main program. So when you enter this subprogram, then everything here, even if you're using, we know that even if you're using the same exact variable names, everything now inside the subprogram as if the main one is suspended and it goes inside. So the calling program is suspending. So the calling program, which is like, let's say the main one, or if it's a nested subprogram, is suspended during the execution of the call program. And then the control always returns to the main one when you're done. So basic stuff, but these are the formal ways: suspend, execute, return. Now let's start talking a bit more about the actual differences and maybe design issue. You don't have to be familiar. We're not going to cover everything here. These are just like from the book. They covered most of the design issues. Again, people like the designers of the program, they want to design this, they are going to ask themselves, okay, do we want this or that, right? So one of the things that I'm going to talk about it now, because we've covered it so many times, is, are local variables static or dynamic? Why? Because I'm going to go inside the subprogram. I have local variables. So one of the main things, am I going to do them static, or am I going to be, they are going to be what? Dynamic. So let's talk about it a bit. What is wrong with this code? So this code is like a function that does the factorial of a specific number. So for example, here I'm passing 5. I'm calling this to do the factorial. Can you see if there's a problem? Let's give it a minute for people to think a bit. So now these are very important stuff, right, guys? For example, if I give you something like this in the exam, you need to be able to know it, because it's not going to be based on actual debugging of the code. It's going to be something very obvious that you need to know. What do you guys think? Who wants to try? Okay, Samuel.
The static n variable is going to be shared across all calls to the function.
So this static end, you're saying because we're having inside the local one, there is a static. But what's wrong? Sometimes we can have static. Why would this be wrong? Like if you continue like explaining.
It's going to overwrite that value in function called 2 because they're all sharing the same.
Guys, what is a static? Static, that it's what? It's static. There is something that doesn't change. It's in the memory. And there is a recursion here. That means as if there is a nested subprograms, right? As if we're writing this this function like 5 times or 4 times nested. But if I'm using a static and I'm passing this, what's going to happen? Let's see it. This will give an incorrect result. So let's see. So we're going to go here. See, I prepared some functions, and we're going to use this time the Python tutor. So this one is what is going to be a C. So let's visualize it together, guys. I'll make it bigger. Okay. So this is the main. This is my stack. Why we're using a stack here? I've talked about this so many times. Why we're using a stack, not the heap? If I'm using a function, yes, Annika? Exactly. Whenever it is something bound to a specific block, to a specific thing, usually it is a stack. So now when I'm going inside this function, because it's local, it's going to use the stack, not the heap. There is other cases where the heap is used. We're going to cover them. But usually by default, local, stack. Why? Because stack is fast. And why from data structure, stack is what? First in, first out? Or is it last in, first out? So if I'm doing recursion and stuff, I need the last in to be first out, correct? That's why we use a stack. Okay, guys? So let's see what's going to happen. So this is my main, the result here is this. So result is calling factorial. I'm going to go inside here. I'm creating another one here in the stack, which is this chunk of memory that's using a stack is for the function. So I have an n, it's going to be 5. Why 5? Because I have a 5 here, correct? Okay. This, if you look at it, it says static. So what's going to happen? Static equal n, so it's going to be 5. Very good. Now, is this 5 less than 1? No. So I'm going to go and do the recursion. In the recursion, I have here static n. It's supposed to be 5 times what inside this? 5 minus, so the function, but I'm going to pass 4 in this case. Look what's going to happen now. I create a different chunk of memory. Why? Because this, as if it's a new function. So it has its own local variables, right? So these are supposed to be local variables for the second call of the function. Look here, what's going to happen in the main, and not the main one, in the first function one. So in the first time I did this. So this is supposed to stay 5. So what's going to happen? I'm updating n to 4 because 5 minus 1 is 4. When I updated this static one here, when I updated this here in the second function, it's supposed to be local. It also updated the one here because it's static, it's not dynamic. It goes to always update. So if I continue doing, now I'm going to enter again, it's supposed to be 3. So what's going to happen? 3, 3, and then look, it updated to 3. So I'll end up with what at the end? 1. If I ended up with 1, now what's going to happen? When it's 1, return 1. So all the static n are going to be 1. So I'm going to be 1 times 1, 1 times all the time. So it's going to return 1. That's not going to work, correct? So if I look at it here, now what's happening to these? These are like going away. It's stacked, it's local. So they are going away. And then I end up with 1. So 1. So what is the simple fix for this? I'll just not put static, dynamic, okay? If I use dynamic and we do it, the same thing, that's 5. So look what's going to happen. Now, when I update this to 4, it stayed 5, the main one here. So that means this is going to be 5 times 4 times 3. So that's the main difference. Very good. So let's talk now. So why am I showing you this? Is because when they thought about choosing something, should we do it static or dynamic? They start thinking, when would static cause me a problem? Someone said, okay, what about recursion? Oh, okay, so maybe we need to make them dynamic. So that's how the design usually will be discussed. That's how the design issues will be solved based on actual things. Now, different programming languages may solve the problem in different ways, correct? And we're going to see that. So stack, dynamic, we said they are bound to storage when the subprogram begins execution and unbound from the storage when the execution terminates. We know that. Flexibility, it is essential that recursive subprograms have stacked dynamic local variables. What are the disadvantages? We also covered this from previous, so now we're just repeating ourselves again and again because these are very important and basic concept that you need to know. So what is the main disadvantage when we have the stack dynamic thing and a local variable? Because each time I'm creating a local variable, storing it in a memory, then destroying it after that. So what am I doing? So I did this 5 times. That means what? What did I do? What did I do in the memory 5 times? Allocation, deallocation, guys. Correct? We need to, by now, you need to know this for sure. Whenever there is the main disadvantage usually that we're always going to allocate and disallocate the memory, this cost. Indirect addressing also accesses to stack dynamic local variables is going to be indirect, not direct. Why indirect? Because each time I have to wait until I call the function, I'm inside the function, and then a specific memory will be allocated. This memory will be what? Different each time. But in a static, it's always that's the address of the static. I know all the time that's I can access this address directly here. But in the case of dynamic, each address will be different each time. Okay. Subprograms cannot be history sensitive. Why? What do you mean by history sensitive? If I ask you about this, history sensitive, that they are destroyed after you're done. So you cannot use the variable or the values from the function. These are destroyed unless you return them and save them, right? If you don't do that, they are destroyed. So history sensitive. Now the static is what? The advantage are the opposite. You're going to save time. There's not like if you want to use it, it's going to be in a specific one memory. It's not going to have to create a new memory all the time. There will be one memory. So that's one of the advantages. So require no runtime overhead for allocation. The allocation is going to be just fixed. And then also it can be accessed directly, as we mentioned. They allow subprograms to be history sensitive. So it's like the same as, so the opposite of the dynamic one. Now, the greatest disadvantage of the static local variable that you always have to remember is the recursive one. That's the usually greatest disadvantage. You cannot support recursion if you're using static. Also, their storage cannot be shared with the local variables of other inactive subprograms. What do you mean? If you booked something, a booked memory for a static one, even if you're not using it now, let's say you used it and you're not going to use it a lot, you just booked this memory. But in the variable, inside like the dynamic, let's say I want this memory to be used only in this function. When this function is destroyed, I'm freeing this memory. Someone, another thing, another program can use the same memory. So it's like there is a memory sharing, right? Now, in most contemporary languages, locals are stack dynamic. We covered this, correct? So we know that always local are connected to stack dynamic, not heap stack. In C-based languages, we also said locals are by default stack dynamic, but can be declared as static. We also covered this. You just put the static thing. And then if you want to make it on a heap, we said, what do you use to allocate memory manually on a heap in C and C++? Malloc, new, delete, right? So these are manual if you want to use them on a heap. We said Java, if it's Java using a heap, it will be automatically, and there is a garbage collector. Now the methods, if C++, Java, Python, and C# only have stack dynamic locals. So the methods of C++, Java, and Python, and C# only have stack dynamics. And last lecture, we said something different. That's you now, if you were awake. So that's what's going to happen. So I'm going, because most of you were, so I'm going to just act as if I'm the student. So the student is going to say, but professor, in data types chapter, you told us all non-generic arrays are fixed heap dynamic. Once created, these arrays keep the same subscript ranges in storage. And then we mentioned C#. And now you are saying the methods of C++ and Java only have stack dynamics. So there's a contradiction now. Because we said in the lecture in the WOOC lab last time that no, Java use fixed heap dynamic. Is this accurate? The keyword here that when we talked about the fixed heap dynamic, we were talking about arrays, specifically arrays. Everything else in Java is stack. So you need to not confuse these things. When we were covering the slides in the WOOC lab, we were actually talking about the array part of the type, so the array, right? In Java, arrays actually are not treated as primitive. They are treated as what, the arrays? In Java, they are treated as objects. And because they are treated as objects, objects will always be on the heap. That's why for arrays, even if arrays are created inside the local function, is going to be saved on the heap because they are objects. We're going to see why. But everything else is going to be stacked. So don't confuse this. So in Java, all arrays, whether defined inside a function or at the class level, are allocated on the heap, and they are considered fixed heap dynamic. This is because arrays in Java are objects, and all objects are allocated on the heap. Maybe you don't trust me, so we're going to see it. So that's the Java code. Let's copy it here and go to the Python, go to Java. Let's visualize this. Okay. So what's going to happen? I'm saying int, I'm trying to create here. So I called this function. So this is supposed to be function. So everything inside is supposed to be local, correct? So if I'm creating this int, local array equal new int 5, what's going to happen? Object. Usually Java deals with objects always. This object is going to be on the heap, and it's going to go in reference to this object. So look what's going to happen. So I'm filling this, I'm updating it. Usually it's supposed to also update here. Maybe if I zoom out, it'll work. Okay, now it worked. So look, so this is the array that's been created is here. So what's going to happen? Usually, okay, usually when we return it from a function, what happens to the local variables? They get destroyed, correct? They get destroyed. That's the normal thing. Look what's going to happen here. It didn't get destroyed. It's still here. Why? Because it's on the heap. The heap doesn't get destroyed. Yes.
The variable that's pointing to the object, that's going to be on the set, but the object.
Yes. Yes. So if we're creating two different things, you're going to see there is something on the stack, there is something on the object. But here now, I destroyed the local things, but the object is still on the heap. And what happens here? I can just take it and continue printing it and everything. And that's the strong aspect of Java compared to C++. Even though this is a fixed heap dynamic, it's on the heap. If you don't use it anymore, that's where the garbage collector will come and it will be automatically destroyed. So you don't just have this unused memory anymore. So this is done automatically in Java. Okay, guys, so that's the main difference. Now, if we play around here, no, I don't have it here. But if, for example, you change this array into a normal variable, just a normal int, you're going to see that, no, it's going to get destroyed. It's on a stack. Okay, so these are very important, guys. I left of the code if you want to also try it by yourself. Now, this is the most interesting thing that we're going to try to cover, because all the other things that I've talked about mostly are the basics, you know them. But now there's something that's about the parameters that we have in subprograms. Parameters have modes. And I think the majority of us always see this mode. So what is this mode? That's a normal program in Java. I have int x, int y. These x and y are what? Formal or actual parameters? These are formal parameters, correct? Why? Because they are here in the function. What are the actual parameters? 5 and y. Y should be defined somewhere. I'm going to find it. And then that int y equals 3. Int y equals 3. Okay. These are in Java called in-mode parameters. Why? As simple as what we just explained. When I pass the 5 and the y, so I pass the 5, I can use the 5, right? So I say y equal x plus y. When I do this, let's actually see it right away. And code, so we don't waste time. Let's see it here right away. So this is y equals 3, correct? So what's going to happen? That's why 3 is here. Even though my formal parameters are X and Y. So I'm still using Y here. But this Y is which Y? Are they are same Ys? No, that's local. So that's what's called in-mode parameter. That means in mode, the parameter only you're feeding it to the function, but you cannot affect it. It doesn't change. So it's in the in mode. You can only pass it, but even if I change the Y here, it's not going to get affected. So for example, we're going to go here. So here, if you look here, I have Y equal X plus Y. So I changed it to 8. Nothing happened in this Y. So Y in the calculator. So this is here inside the function. And then when I go outside the function again, the result is what is 8. So the result returned from this function, but this Y here, if I print it here, Y in the main function, if I print it again, it's going to stay 3. So that's called in mode. We all know this. But is there other modes? Actually, there is. Eric is agreeing. Have you tried other modes in any other languages?
You can see it's pretty common. You pass in like a pointer, and then you get out the value from the pointer. The function only returns it.
Very good. The C is very interesting case. We're going to cover it. So before we move, so this is called in mode, correct, guys? So the in mode usually is implemented called by parameter by value. So it's passed by value. That means, what am I doing here? I'm copying. So it's like this. So this value that I passed, I copied it here. I copy. So it's copy. I cannot touch it. Nothing. It's called passed by value. That's in mode. Now let's see other languages that do something different. So that's Ada. It's not very popular, but Ada usually is one of the very few languages that actually support explicit modes. So you can actually explicitly say in integer. So A is going to be what? In mode, or out mode, or in out mode. Okay, so let's check them. What do you mean by this? If we copy this, we go Ada online. Yes.
Like in, out, use more like hardware definition languages,
Hardware definition languages?
HDL.
For what?
Like for like VHDL, I know they have.
Yes, like lots of languages have different things, but here, I'm not sure if these in and outs are the same with the VHDL. I'm not very familiar with the hardware language, but like here, if I want to look at this, guys, so this is my program here. Okay, so that's the program that I'm defining. I'm saying A, these are the formal parameters. So A is in integer, B is in out, C is in out. Okay, so that means I'm here. Okay, these are my variables. X is 12, Y is 44, Z is 30. So look what's going to happen now. I'm going to pass, these are my what? My actual parameter, correct? So I'm going to pass X, Y, Z. So I'm passing X here. X is in mode. So when I come here, if I want to print this, is going to be what? 12. Okay, and I cannot touch it. I cannot change it. Even if I change it inside this function, it's not going to affect anything outside. But if I look at B, guys, B called out integer. That means what I'm passing here, this Y is 44. But what I'm not passing 44. We're not very familiar with this, but that's actually how it works. It's actually passing an empty container, like it's telling, okay, I'm passing this container to you without a value. This container is what is an integer container. So it goes here. So that's why the container of Y is here. I cannot use B. So look, if I call this, if I modify this and I do this, I do Sorry, let's delete this first and let's try to print B. Okay. I want to print B. 0. Because I'm passing a container, I'm not passing it. The out is I'm passing a container. Okay. But A, it printed A 12. Why? Because it's in mode. Now C is in out mode. So in out mode is mixed of both. Okay. I'm printing 30. But now, when would B get activated? You need to give it a value here. So you're passing this container, which is Y, you're passing it, and you're saying B is now equal 100. So let's track it. When I'm printing here outside, so when I'm printing Y, it changed. It's not 44 anymore. It actually changed to 100. So that's the difference. This is state 12, this is in mode. Even if I change it inside the function, it's not going to affect anything outside the function. It's local. Out mode is what is, I'm just sending an empty container and I'm actually changing it will actually change the actual value outside. The in out is both. I'm sending a value that can be used here. So this value can be used inside this function, but also if I change it like this, it's going to also affect the one outside. It will work for both. Now, if you look at it, you may say, why is this? If we want to change something, we can just do in mode like in Java and then return, correct? That's how we do it in Java. We just return a function, return something, and then inside here, I'll say, for example, y equal the returned number from thing. These are based on design decision that people made, and they saw, why would this thing, what would this design here be? When it comes to the stuff that we work with, like readability and other things. Why this is important? Why Ada designer said, no, I want to actually specify if this is an in or out. Michael.
For safety.
Exactly. Type safety, which is linked to which one of the reliability? Now, I'm very happy we're able to actually, I don't have to give you, you're going to be able to analyze it. So that's actually design decision that Ada said, you know what, no, I want it to be very reliable, this language. I want to be super strict when it comes to these things. Because, for example, as Eric said, other languages like C++ will allow you to modify using what? The reference, right? The pointers. But what happens with the pointers is the collision, there's other things that can cause things. So Ada designer said, no, I want something super explicit, super reliable, because pointers are not reliable. Maybe collision will happen. Maybe I forget to delete a pointer or something. So are we able to understand now the idea when it comes to the design decision that the languages are taken? Now, in and out, as I said, it's both. So if I look here, so this is the same thing we said, that's what's going to happen. Ada is one of the few programming languages that supports in out and explicitly. And I actually just explained what we did in the code in case you want to review it. Now, this is the abstract idea of in mode, out mode. So the in mode is actually, that's the caller. So it only goes this way. It cannot return anything, like whatever, even if you change whatever, it's not going to return. Out mode, you don't even pass anything. Like even if y equals 40, you cannot use y. You can't. It's just like as if you're just passing a container. In out, you pass it, they use it, and they can modify. Yes.
Oh, for the first one, when you say call, you're just sending the values, and the values that are being modified, you can't access it in the caller function.
The in mode?
Yeah.
So yeah, you're sending, like as Java, you're sending X and Y, and these X and Y are like 5 and 10. So we can use the 5 and 10, we can use X and Y, but if we modify X and Y inside it, it's not going to affect the X. So you're copying, it's called passing by value. So I'm copying the value inside the new memory and then use this value that I gave you and do whatever you want, but it's not going to affect me. So that's the idea. Now the out mode is called pass by result. It's pass by result. Okay. Why? Because I'm going to just pass you the a container and going to give me what here? What is passed here? The result. Okay. In and out is called pass by value result. So I'm passing a value, I'm giving you a value, but also you're giving me a result. Okay. So these are the three main modes: in mode, out mode, and out. Now, C# is another language that support explicit modes. So in C#, because some of you maybe have used C# before, you're going to find things. So something like this: out and result. That means this result is only out mode. So if we do this, I'm not going to spend time, but it's the same exact idea. You're going to notice that before execution of the function, it's 2. After, it's going to be 42 because I actually changed it. So what are the few differences? So here again, both of them, they find, okay, this is very reliable, but C# went one step more. They said, look at ADA. You have to have A as in, but when you're passing it, you're just passing X. In C#, no, they went a step further. They said, even if I'm passing the number, I want to also specify this is an out number. If you don't, it's going to give you an error. Now, what else? C# is also another thing. So do you remember here? It gave you 0 if I tried to use B, right? It gives you 0, it gives you usually a warning. So usually it gives you a warning in a real compiler. In C#, it's going to give you an error. No, you can't use this B. What are you talking about? Error. Here, no. Okay, you know what? Be careful. Is 0, continue. So that's also, that means C# took what? A higher step, or like a further step. So all these differences, as we said, are based on the design decisions when building the language. Now, how are these done? We said the in mode parameter is used when the parameter only needs to be read, not modified. Out mode is usually when we want to modify, and out mode is returned. So now, why are these important? Usually the discussion will be with the designer: only value, only address, address and value, read only, write only, read write only. Pass by value. So as we said, the in mode will be pass by value. So what is the main thing that you need to always remember is that pass by value normally implemented by copying. Okay, the disadvantage of this is what? Additional storage. We've talked about this so many times. Because it's copying, that means I need to, in the local, I need to book a new memory for it. Okay, at this point, it's so obvious for us. What about the pass by result? Pass by result, no value is transmitted. Okay? No value is transmitted to the subprogram. The corresponding formal parameter acts as local variable. Its value is transmitted to caller's actual parameter when control is returned to the caller by physical move, blah, blah, blah. Now, pass by value and result are the mix of both. So we're copying it, and also we're returning the result. Now, we talked about the in-out mode, right? We said in-out mode can be passed by value result. But there is another way that in and out mode can be used in C++, which is called pass by reference. Pass by reference, that means we're actually passing, we're using this. Do you remember when we said this thing may have an ambiguous use? Why this thing may have ambiguous use? Because if you give it A and B, it's going to be used for something as an operator, but also this operator can be unary and binary. Do you remember? We gave the example of this one, the end. So in this case here, look what's going to happen, guys. I think we're out of time. So we're going to continue in the tutorial session to finish this, and then we go. Okay? Again, I apologize for being late. I prepared so many codes and everything, but I was not lucky today. But we'll continue in the tutorial.